Hello everyone, this is Gautam. Today I am here to do a video assignment on the topic of propositional logic 2, plausible reasoning, a uniqueness theorem. It is based on the research paper abstract. Here we are going to examine the question how the propositional logic it extends to a logic of plausible reasoning, and it has four conditions in any such extensions how to meet. In each condition, there is some feature of the classical proposition should be preserved in an extensional logic. As such, the conditions are less problematic and simpler than the Cox theorem and its variant. Introduction. Here, the text inquires into extending classical propositional logic to the range of certainty using probability theory, deeply rooted in the concepts of Pola and clocks. Their probability rules are set of distinctive, consistent inference or plausible reasoning, rather than merely those calculations. This research paper is mainly based on the work of the co- work of the co- work of the Polly and Cox. These are the two well-known research persons. They spend the time on doing these classical propositional logics. So here the aim of doing this logical consequence relation is one oriented to certainties such as to portray degree of credibility. It would give rise to concept as such as plausible function, where C dot these are which is represented as you can see in the screen, where A is judged to plausible a sentence or proposition, where A is known in other sentence or proposition is called conditional. Here X is true, and it may be a true consequence. Here we intend to define in general and then particular cases true of consequences. Recall for the purpose of the questions, and this approach treats probability as a continuum extension of logic with coherent rules guiding all degree of probability inference consistently and aims at codify probability theory as an essential necessary extension of classical proposition. Research question. Here as as coming back to the topic proportional logic to plausible reasoning. Here through the unique through the unique theorem, so we are proving is so here they are proving the theorem which uh, which changes from proportional to probable proportional theorem to in the general method of constructing the neat sequence of approximating formulas. Any computable probability measure, extending our language of propositional formulas to express the measurable set beyond the cylinder set, where ensuring that p of x remains computable as appropriate for the logic system. So we are trying to prove a theorem from the propositional logic to a plausible reasoning by utilizing the various works of the different resource persons where we are proving the we are proving with the help of theorems and formulas where we are able to justify our end result. So here as moving to the literature review R1, if x and y are logically equivalent and a and b are logically equivalent assuming x, then a is equals to x is equals to b. In this case, uh, where x and y are logically equivalent and AB are logically equivalent, then we can consider x is equals to A and y x is equals to B. So here we can conclude that y is equals to A and y is equals to B and x is equals to A and x is equals to y. In R2, we may define a new proportional symbol without affecting the possibility of the any proposition that does not mention that symbol specifically if if S is a proportional symbol not appearing in an AX, AX or E, then X is equals to A, S belongs to E. Then adding irrelevant information to the premise does not affect the plausibility of the query, specifically if Y is a satisfiable proportional formula that uses no proportional symbol occurring A or X, then A is equal to X is equal to A, then Y a conjunction X. The implication ordering is preserved if X is equal to A implies B, but not X is equal to B implies A, then possibility value is strictly less than B. Where in the above condition where A implies to B, where A which is equals to X, then B implies to A which is equals to X. If the X plausibility is strictly lesser value, when the condition does not satisfy with this, where X is equals to A comma B, but not B where X is equals to B implies A. If this condition is not satisfied, then the X is a then the A implementation A implement X is a plausibility value that is strictly less than B. Data analysis and finding. In data analysis and finding, we have Carnap logical probability. Carnap undertakes an extensive investigation of logical probability. He mentions two notations of probability, which is probability 1 of a epistemic probability, where in this probability we see that the degree of confirmation of a hypothesis H with respect to an evidence statement E, and the probability 2 is a relative frequency. Carnap was seeking the general inductive rule, which says the rule by which, given the record of past results, one can make the best possible prediction of a future one. By using the past results, Carnap, Carnap general inductive rule able to predict the future ones. But he never rises to level of seeing that different inductive rules corresponding to different prior information. It seems just too obvious that the primary factor controlling induction, without which the problem cannot be stated, much less solved. much less much less solved. There is no general inductive rule. Yet neither the term prior information nor the concept ever appears in the NAP's opposition. Here in the function, if we consider a bijection between one and here we excluded B and W, which is a dynamic rationals where m divides to n, which has a possible binary expansion. Furthermore, both f and f minus 1 are the measurable. Then we have the given equation. Then finally f is a measuring preserving, where it guarantees the PR of A as in the given equation, and therefore we can apply this theorem to satisfy the condition which potentially proves our theorem. What we are trying to do. See, here consider any finite set of symbols where S and T, and if S contains k additional symbols beyond those, then we have the values as given here, and thus we may use any suspect of the symbols appearing in A and X. With evaluating A and X, A implies X. We consider each of the requirement in term. R1. Let X is equals to Y and A is equals to X, B and S. That implies A comma X, A comma B comma X comma Y. Then S comma X is equals to hash of S comma Y. Hash of S comma X is equals to hash of S comma Y. And hash of S E conjunction X belongs to hash of S B conjunction X is equals to hash of S B conjunction Y. Hence A is equals to X is equals to B. So using all these um, all these values of the proofs which are already existing, we are proving that X is equals to X belongs to Y, where case Van Horen internal reasoning, which is taken from the Bernard's box paradox, which is here. Here we have D11, D12, D21, D22, D31 and D32. Here, which gives us the as per the given data, we get the output as GGG and SSS, SSG, SGG, GS, GG, SS, SGGG, SS, SSS, GGG, SSS, GGG, SG. And we have the graph how the predict how the prediction goes. And and moving on to conclusion, it's moving on to conclusion, what we can able to finally 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 make it out. It serves as a strengthening case that natural extension of CPL is probability theory of plausible reasoning. The present system meets simple obvious intuitive requirements harder to quarrel with than other proposals, while retaining the good features of CPL, of course essential for this strategy in that relation of plausibility between A and X depends solely on the arguments A and on the relevant information provided by the arguments X. The current method of Crab's approach and connects probability with the structured plausibility ordering, then it is also capable of alignment with rational probabilities. Hereby, thereby we can clarify and conclude that classical definition of probability by overcoming the criticism by the existence of uniform infinite probabilities via latent variables and the limiting processing in order to treat infinite domains, which is ensured by measure theory. Here we are able to finally achieve what we are going to establish as mentioned in the above, proving the proportional logic to the plausible reasoning by using various theorems, which is already proven. And with the help of these theorems and various aspects from the different researchers and different works, we are we are able to aggregate all into the one under one umbrella, where we can finally prove our where you can finally say that the finally prove that we are able to achieve the proportional logic to plausible reasoning. Thank you, one and all. Have a great day. Please do like, comment, share, and subscribe.